Okay, so today we are going to look at some equations of lines in standard form. What is standard form? Well, let's find out. Okay, so yeah, basically the goal for this lesson is we're going to want to write the equations of a line in standard form and just be able to convert it into standard form if we have a line in some other form. So, unfortunately, not for you watching this video. If you're in class though, you get to do this activity. All right, so the actual rules for standard form are these following things. So in equation, we have to make sure all of the variables and numbers, besides the 0, are on one side of the equation. So whether it's like 2x plus 3, that's one side of the equation, or 0 equal to x plus y, one side of the equation. So that needs to be true. Next, the order that we write things in, we do have a specific order, and it's kind of like alphabetical order. We write x first, then y, then whatever our number is. After we write things in order, we just also need to make sure that the number in front, so like our coefficient, so if we're looking at these examples, whatever number's in front of the x, that always actually has to be positive. It's a very specific rule. And sometimes in this general form that we've written here, we say that the value of a itself must be bigger than 0, as in positive. And the last part is we have to make sure there's no fractions or decimals. We want just integer values, whole number values for the coefficients of our numbers, or like for our variables, and the actual number if there's a number involved. So let's actually look at some examples. But I do just want to go over this alternate form. So sometimes alternatively, what happens is that instead of writing like 5x plus 2y plus 7, all the parts, the x, the y, and the number on one side, the alternate way that you might see online as well too is to write the x and the y part on one side and set that equal to some number. So that is still like a legitimate standard form. But for the purposes of our course, we're going to go with this form here. The numbers and variables all on one side. But I just wanted to make sure that you were aware of this other standard form that you might see if you're looking things up. Okay, so let's go ahead and circle the equations in standard form. So what do we need to look for? Well, we need to make sure, let's look at this first equation. This first equation has a fraction right away. That's bad. So we need to make sure things aren't fractions. So right now, no fractions or decimals. That's good. Things are in order. You have x, you have y, you have a 4. The number in front of the x, the 7, that's positive. So that's good. And it's set equal to 0. So this one is standard form. All right. What about the next one? X equal to 5. So with the standard form that we're using, the number has to be on the same side as the variable. So we're going to nix that, not standard form. Next one, you might see that there's no x in this next one, like where is x? But that's okay. I mean, you don't have to have all of the variables. You just have to have whatever variables that you have on the same side of the equation. So in this case, it's on the right side. You have it subtract a number, and it's set equal to 0. So that is standard form. This next one, y equal x minus 4. Well, take a look. Y and x, they're variables, but they're on opposite sides. So that's no good. This, everything's looking good so far. We have x, y, number. X is positive, set equal to 0. So that is standard form. And again, we can see here, y equal to 6, This is one of those cases where you have a number and a variable on the other side, so we're not going to count that as standard form. But if we have everything on the same side of the equation, the number in front is positive, that will be standard form. And again, we have everything on the left side of the equation. We don't have a plus or a minus a number, but that's okay. Sometimes you don't have that extra number, but it can still be standard form. Y equal to 5x squared plus 8. What's going to happen with that? Well, in this case, you have y and 5x squared. They're on different sides of the equation. So that is not standard form. Eventually, actually, next year, you will look at things with exponents and like what their standard form is. But for now, we're just looking at lines. Y plus 8, you have your variables. In this case, only one variable. And your number on the same side. So that is standard form. The last one, there is a couple of reasons. You can see there's a fraction, so that's no good. The variables are on opposite sides, so in the end, that's just not standard form. So we have those following ones that are in standard form. So take some time, double check, and you can see those patterns start to emerge more and more as you keep going through different types of equations. All right, so our goal now is to practice converting into standard form. So we'll take a look at these examples to see how we do that. So let's take a look at y equal to minus 7x plus 3. So this is going to end up being a lot like solving equations, but we're not actually solving for a particular value of a variable, but we are moving things around in the equation. So we need to get all our parts to one side of the equation. And what I'll say is we have 7x here. Let's move that to the left side. So this minus 7x, that's one full term we're moving over. So since we're moving that entire thing over, right now it's negative, we have to add it. So it'll be y plus 7x equal to 3. All right? And we're going to try to get it into our version of standard form. So we want to move this 3 over 2. So we need to move it to the left. And if we're moving it to the left, that 3 is going to become minus 3. So it's going to be y plus 7x minus 3 equal to 0. Once you have that, this is standard form. So no extra work is needed. You don't need to solve anything. We just want to move parts of the equation over to the other side. Okay, let's take a look at this next one. So you might be tempted to start off the exact same way, move this 3 over and then move the 5 over afterwards. And that would make total sense to do that. But I'm going to take a look at this in a different way. And the reason being is that right now, the 3x that we have, that's a positive number. And one of our criteria is that coefficient of x it must be positive. And so if we were to move it over, you'd end up having like a minus 3x, but then, I mean, we don't want negative number. So we're going to actually leave the 3x there, and instead, we're just going to move the y over to the right-hand side. So if we move the y over, right now it's positive y, so you can subtract y. And y minus y, that leaves you with just 0. There's nothing left on the left-hand side. And you're going to have 3x minus 5. You might be tempted just to write it on the end like that. But then, remember with addition and subtraction, you can rearrange your addition and subtraction. So in a sense, like negative 2 minus 3 is negative 5, but negative 3 minus 2 is also negative 5. So the order of subtraction, as long as you keep the signs in front of the parts that you're moving around, can be changed. So that's what we're going to do. So we're going to slot this minus y just in front of the 5. because we want to make sure we're in the order of x term, y term, number. So we're going to have 3x minus y minus 5. And there we have our standard form. All right, let's continue along. So this next one, things are looking pretty promising. We have y and x on the same side. We just need to get this 1 over. So let's do that first. Move the 1 over. So right now it's positive. So if we move it over, we're going to subtract it. And that's going to be a prominent theme throughout these converting to standard form. A lot of addition and subtraction happening as we move our terms over. So minus 1 equal to 0. We also need to take into account that we want things in the correct order. But there is also one last rule we need to take into account. And the last rule is we don't like fractions. So if you have a single fraction like we have here, what's the denominator of that single fraction? It's a 4. So what we can do is we can multiply the entire equation by 4. And this is a neat little trick that will allow us to write an equation that means the same thing, but in a sense we're just scaling it so that it doesn't have a fraction anymore. So if we multiply the entire thing, what do we mean? We literally mean we're going to do 4 times, well, the 7 over 4x. We're going to do 4 times the y. And we're also going to do 4 times the 1. So every single part gets multiplied by 4. And even technically, you do 4 times 0, but 4 times 0 is just 0 itself. And the reason why we chose to multiply by 4 is when you multiply this fraction here, well, you have 4 times 7 over 4. The 4 and the 4, in a sense, they just cancel out. And you're just left with 7x plus 4y minus 4 is equal to 0. And so there you have it. We now have standard form. All right. Let's take a look at this one. So in this one, we have negative 4x. So that's already a problem. Like we don't want negative x. We have it on the same side as y. So that's looking nice. And we have this negative 11. And there are alternate or different approaches sometimes to solving and converting these. What I'm going to do is let's move this negative 11 from the right side to the left. So if we want to move it over, we're going to add it to the left side, and that will get us to the following equation. And this following equation is it's really close to standard form. We have no decimals, we have no fractions, things are in the correct order, but we just have this problem of the minus sign. So what can we do about that? Well, here's another thing that will be helpful. We can flip the signs of all parts in the equation. So just like in the previous one where we multiplied every single part by 4, here we're going to change the sign of every single sign that we have. So instead of negative 4, we're just changing that to 4x. Instead of minus 7, instead of plus 7, we're going to turn that into minus 7. So negative becomes positive, positive becomes negative. This positive, well, that's also going to become negative. And that's equal to 0. And how does this work? Well, what you're doing is you're actually doing something very similar to the previous one. But instead of multiplying by 4, you're actually, in a sense, secretly multiplying by negative 1. Because if you multiply by negative 1, you're not changing the actual values. 4, 7, 11 would stay 4, 7, 11. But the negative part changes the sign of all of your parts. All right, let's take a look at 2 final examples as we practice further converting. All right, so next we have this one with fractions, but multiple fractions this time. Before we deal with the fractions, let's just get everything over to the same side. So since we have one thing on the left side, let's just move that part to the right-hand side. And it's negative 2 over 3x, so it's going to become positive 2 over 3x. And so you're going to be left with 0 on the left, positive 2 over 3x, plus y over 5, plus 4. All right, now what do we do with these fractions here? So in the case if you have multiple fractions, you kind of want to think of it like when we were adding fractions together. And you want to use the common denominator. So what's a common denominator for these? In this case, you could use something like 3 times 15 is, or 3 times 5 is 15. And so that makes your common denominator. And so we've looked back to the previous example, we had multiplied the entire equation by 4 because that was our one denominator. Now we're going to multiply all the parts by the common denominator. So you're going to multiply equation by 15. Okay. We're not changing the equation because you're doing it to all of the parts. So it still has the same meaning, it's just you're in a sense scaling it. So 15 times 2 over 3x plus 15 times y over 5 plus, well, 15 times 4. I'm just going to write those in red. So it's that 15 there. That's the new part. But as long as we do it to all, that's acceptable. All right, and let's do some math with that. So you're going to have 0 equal to, well, 15 times 2 is 30. So 30 over 3x plus 15y over 5 plus 15 times 4 is 60. And I mean, right now you're thinking, oh, there's still fractions there. That doesn't look right. There is one last thing we can do. The reason why we chose 15 is you're going to see all of these fractions will be able to divide neatly. So 30 divided by 3, well, that is just 10, so 10x. 15 divided by 5, well, that is just 3y. And then the 60. And now this equation here, that is the one in standard form. All right, we're very nearly at the end. So in this last example, 4x plus 0.5y minus 3 equal to 0. It's really close to standard form, but you just have this 0.5. That's the only thing, that decimal, that's messing things up. And so if you have a decimal, what you can do is kind of the opposite of what we did when we had a fraction. So when we had the fraction, we took the denominator of the fraction, or it took the common denominator, and multiplied by that. When we have a decimal, what we can do is identify that decimal and divide the equation by that decimal. So in this case, divide the equation by 0.5. And what's that going to look like? Well, you're going to have 4x divided by 0.5. It might not look nice right now. But we're just dividing each of the parts. And I'm doing it as a fraction. I'll just do it in this red color so you know what's new and what's previously there, equal to 0. All right, but then you can actually do the division. Like, what is 4 divided by 0.5? Well, if you take out your calculator, dividing by 0.5, that's actually just doubling the number. So it's going to actually become 8x. 0.5 divided by 0.5, you're dividing a number by itself, so that's just one of the variables. So you can just leave it as y, because if you were to write down 1, well, it's the same as just writing it like that. 3 divided by 0.5, well, that's the same as 6. And that's equal to 0. And so there we have it. So that's one way of dealing with a decimal. Another way you could do it is you could also just treat 0.5, convert it into a fractional number, which is 1/2, and then treat it like we did with previous fractions, where you just multiplied by the denominator. That's an alternate method. I just wanted to show you a couple different ways for that. All right, so that is standard form, and that is some examples of standard form, along with just a number of ways to convert into standard form with various setups.